Recursive sequences are one type of sequences we're going to look into, and what's special about these is that they use the previous term to find the next term. Now, sometimes they use only one previous term, sometimes they use the previous two terms. What students find tricky about them is the notation. Now, we have a general term for the arithmetic sequence, for geometric sequence. For the recursive sequence, the general term the general formula for the term will include something like n minus 1 or n plus 1. So what n plus 1 tells you is to find the next term. What n minus 1 tells you is to take the previous term. So just be aware of which n you're looking at, which subscript you're looking at, n minus 1, n plus 1, or even n. With examples, this is going to be clear. So if I have something like -4, -3, -1, 3, and 11, it doesn't seem like this has an arithmetic sequence or even a geometric sequence. But what I can notice is that it has something like I can see that I'm adding 1, and then I'm adding 2, I'm adding 4, and then 8. So what I'm doing is I'm adding powers of 2 every single time. This is not the same as multiplying by 2 for geometric sequence. But can I use the previous term to help me find the next term? Well, if I look at -3, in order to get -3, I can take -4 and then add 1 to there. Looking at -1, to get -1, I can take -3 and then add 2 to it. And then to get 3, I can take the previous term, which is -1, and then add 4 to it. To get 11, I can take 3 and then add 8 to it. So what happens here is that I'm taking the previous term. So to find un, your term, your third, your fourth, your fifth term, I'm going to take the previous one, and I'm going to add to it a power of 2. Now the power of 2 is going to change. This is my first term, this is my second term, this is my third term. If I'm looking at the third term, I'm always taking 2 less powers of 2. And you can test it out. So you can pause the video, test this out. You can see that this is I'm trying to find 11, which is the fifth term. And this is the third power of 2. So 2 to the power of 3. So this is one way of doing this general term. I'm using the previous term to find the next one. So in order to find the sixth term, I'll just take 11 and then add the fourth power of 2. Now this is one way of writing this recursive sequence. There's another general term that I could use. There's this one as well. I can take the previous term, multiply it by 2, and then add 5 to it. I find the first method more intuitive. This one you might need a bit of messing around to see how this would work. So there are many general terms you could use as long as you're using the previous term. Now whenever we describe recursive sequences, we always talk about the first term. So the first term is -4, because if I'm always using the previous terms, what term will I use to find the first one? There's no U0. So whenever we describe recursive sequences, we describe the formula and then we describe the first term as well. So you need to have a head start. So there's an alternate way as well. So if I want to say I want to find un plus 1, I'm going to use the previous term, which is un plus 5. So there are different ways of writing it. So you can pause the video, just have a look at them. All this tells you is n is the term, I'm using the previous one, n minus 1, or n plus 1 is the term, I'm using the previous one, which is n. If I have a different example, so hopefully you'll notice that this is I'm multiplying by 4 every single time, but the signs are changing. It goes from positive to negative, which means I'm actually multiplying by -4. It's not multiplied by -4 every time. It's you're taking the previous term and multiplying it by 4. So I get -4 un minus 1. Now sometimes recursive sequences are geometric sequences or they are arithmetic sequences. They can be, or sometimes they're neither, like the previous example. But we sometimes use the recursive sequence, the general term for it, because it just makes finding the next term a bit easier. And again, I could just change the notation and say n plus 1 or u, and then use the previous term un. Sometimes instead of u and n, we can use other letters, so we can use k instead, so that's completely fine. And you could pause the video, practice how to find the expressions for these. So to find u2, you're going to take, so this is, we'll have 5 here as the first term, and then to get u2, you're going to go u1 squared minus 2, so that's 25 squared minus 2, so that's 23, and so on. So it's easy to find the next terms once you have the previous one. This is another example, and hopefully you can notice you're subtracting the previous term by 4. So always, whenever you're looking at recursive sequences, don't think arithmetic or geometric. Think of how you can use the previous term to find the next one. So we're subtracting the previous term by 4, so I can say, okay, to get the next sequence, I'm going to take the next term, I'm going to take the previous one and subtract by 4, and my starting term is 12. This is another one. 2 things you'd notice is that you are alternating the values. You'd also notice that the digits are the same. What's happening is the decimal place is changing. So what we're actually doing is we're multiplying by 10. So we're multiplying the previous term by 10. Signs are alternating, so we are multiplying by a negative 10. So 2 observations to make. So if I want un, I'm going to take the previous one, un minus 1, and then multiply by negative 10. And the starting term is negative 0.32. Hopefully you're noticing that I'm changing the type of notation. Sometimes it's n minus 1, sometimes n plus 1. So I just want you to be more comfortable with the different uses. But both are exactly the same. This is another one, and you could pause and try it on your own as well. Hopefully you can see that you're dividing the previous term by 5. Again, always use the previous term to find the next one. That's how we can describe the recursive sequences. So I'm taking the previous term divided by 5, and my starting term is 500. So hopefully this was clear, and how do we end the video? So with recursive sequences, it's just a matter of practicing as many sequences as possible. Finding the terms using the sequence should be easy. It's just a matter of knowing how to read it. So this is using a previous term divided by 5 and so on. And then writing the recursive sequences, sometimes students struggle, but do just think, okay, how can I use the previous one to find the next one? And can I find the pattern, the same pattern for all the other terms? And as I did with the first example, there are many different ways of writing a single recursive sequence. Maybe there's only one, but there might be more. So it's just a matter of practicing and seeing which one you can come up with.